Hello everyone, we're talking about functions again today. Specifically, we're going to talk about quadratic functions and even more specifically, how we come up with an equation when we have some information about a given parabola. So for this specific example, we've got a vertex. We've been told what the vertex is. And from our previous explorations and courses, we know that when you know the vertex, you can use y equals a x minus h squared plus k to define the quadratic function. Now, what we know is that we can plug in for h and k the vertex. So let's do that. We get y equals a x minus 3 squared plus 7. Okay, we could simplify this a little bit by writing it like this. Y equals x plus 3, two negatives here, making a positive, squared plus 7. Now, we know this. What parabolas could this be describing? So what we got is all I put in here, you'll see in the orange here, is I put in this vertex. So I have the option of changing that front number, the a value. Okay, and as I do that, you can see any number bigger than 1 will make it kind of narrow. Any number less than 1 will make it nice and wide. And then if we go negative, it's going to flip it over. So in other words, what I'm trying to get at here is that when you have only the vertex in, it actually describes a lot of different parabolas. Okay, this one, and that one, and that one, and this one, and all of these ones, and way more too, because I've kind of narrowed my search here. But if I made this number here, say minus 200, and then I just kind of looked at all of the possibilities, you can see there are a lot. That one's like a super narrow one. It's going to widen up and flip over, and you can see that there's an infinite number of possibilities here, but they all have that same property that the vertex is at negative 3, 7. So let's leave this again for a second. We'll go back in here. And we'll take a look at trying to get it narrowed down to a very specific parabola, just one parabola. So what information would we need to know in order to do that? Well, all you need to do is provide a point that it goes through. So now we're going to say it has to go through negative 6, 25, and we're going to try to figure out what that number in front would have to be. So let's put that point on our graph. So you can see I'm way out right now, so it can't be face down. None of these work. As I go up, oh, you see I'm getting closer now. And when I get right there, right there, it goes through the point I want, and I know my a value has to be 2. So I can go over here, and I could say, I know it's going to have to be 2 now. X plus 3 squared plus 7. That will make sure it has the right vertex and it goes through this point. Now you might be asking yourself, well, what if I don't have a graphing calculator program to do this? How would I do this otherwise? Well, even better, we can go ahead and try to do this with algebra. So we start off with knowing that we need this to be our point, and our vertex has to be equal to minus 3, 7. Okay, so we've got a, because we're going to pretend we didn't know that that has to be 2. We've got x plus 3 squared plus 7. And then we're going to plug in the point that we need. Okay, so what we're really saying is that we're going to feed in some information about this function. We're going to tell the function that when you put in a minus 6, 25 has to come out. Okay, so let's do that. Let's just write in that. We're going to put a minus 6 in here. Okay, we'll leave everything else the same. And then we're going to say, okay, when you do put in that minus 6, you have to get out 25. Now, what does that do to the equation? Well, It forces one value for a. Only one value will make this true. If you put in 100 here, it won't give you 25 out here. But we're trying to tell it has to give you 25. So now we just use algebra to try to figure out what a would have to be. So we get a is equal to minus 3 squared plus 7. So we're just following BEDMAS there. Okay, we'll square that. We're going to get 9a plus 7 equals 25. Well, what number do we have to put here? This whole thing has to be 25. Okay, you might be able to see it already. Maybe you see that a has to be 2. If not, let's use some algebra tricks. Okay, we'll subtract 7 from both sides and try to isolate that a. Okay, those will go away. We get 18 over here is equal to 9a. Let's divide both sides by 9 now to wrap this up. Because we don't want to know what 9a's is worth. We just want to know what 1a is worth. So 1a is worth 2 then. And now, one common mistake is people get kind of stuck in the thing that they're doing. So they do all this algebra, and at the end they get this a equals 2 thing. Well, that's not what we're trying to do. We want the equation of the parabola that has these properties. So in order to do that, we need to write out the equation at the end. So sometimes people get stuck in that step, and then they don't finish it off. This parabola is the only one, this quadratic function, is the only one that will have a vertex at minus 3, 7, and will go through the point minus 625.